Hi, Kevin Dorma. I'm back from camping. I was out camping west of here, out closer towards the Rocky Mountains. And the problem that we had was the barbecue would not light. It would not stay lit. And so I'm back at home, and I'm with my barbecue, and I thought I would provide just a bit of a mock-up to demonstrate the symptoms that we saw, and I'll give my thoughts on what I think happened. So I have a natural gas barbecue, but I put a few things in place so that we can see it. First, out there in the West Country, we had a big propane tank. Well, I don't have a big propane tank. I got a little one, so we'll just imagine that's our big propane tank. And there's the high pressure gas line that runs over to the barbecue. And the regulator is over here fairly close to the barbecue. And I've just got a set of vice grips clamped on to represent the regulator. Okay, so, and if you want the symptoms, go check the link up in that corner and check out the video, it's about a minute and a bit, that describes the symptoms. So go check that out, then pop back and we'll finish up. Okay, so what were the symptoms? Well, the main symptom was that the regulator had a bunch of ice on it. So how do we get that? Now, propane vapor is reasonably ideal. So if you take propane vapor at a high pressure, say, the line might be 150 psi, it drops temperature a little bit, but not a whole lot. But if we depressure liquid propane, it goes down to the atmospheric pressure of about minus 40. It goes down to atmospheric pressure, and the bubble point temperature at that is about minus 40. And that is, well, that's cold, and that can make ice. So there was liquid going into that regulator. Now when the pressure dropped across the regulator, it dropped the temperature really low, down to about minus 40, and that's why we saw ice. But the question is, why was this thing full of liquid propane? Why? Well, we have to back up about a couple of days or so. It was really hot out there. Daytime highs were running about 30 degrees. Didn't cool off much. It might have been 20 degrees or so in the evening or the wee hours of the morning. So the average temperature was probably around 25 degrees. And it was like that for a couple of days, actually more like a week. So this great big tank was probably warm. So let's suppose that tank temperature was the average. It was about 25 degrees. So that means the liquid inside is bubble point liquid, and it's producing a bubble point, or probably a dew point vapor coming out the top. So this line would be filled with dew point vapor going into the regulator and then into the barbecue, and that's fine. But that afternoon, the temperature dropped a lot. It was about 10 degrees when we were barbecuing. So what happened is the vapor inside that tank at its dew point of 25 degrees suddenly went into this nice hose and lost heat because it's only 10 degrees outside. So this acted as a condenser. And because it's 10 degrees, it's cold, and that is what was condensing all of the propane back into liquid. And it just pooled in this low area, and it went right up to the regulator. Okay. Now the other symptom that we saw a little bit later on was that the frost on the line going up into the barbecue was creeping up higher and higher and higher and higher, and at the highest it was about a foot, about that high up off the regulator. Well, the regulator pressure is about 8 or 10 inches of water, so propane is about half the density, so that would be 16 or 20 inches of liquid propane. So what was happening is not only was there liquid here, liquid was flowing through the regulator, then it was actually filling up this line with liquid propane until there was enough back pressure that it would cause the regulator to start pinching off. So there was precious little flow rate trying to squeeze through that regulator, and so we were starving the barbecue of vapor. So what happened is when we replaced the big cylinder and put on a small cylinder with the regulator attached, so we did this, we put the little cylinder here The regulator was installed like that, and that worked just fine. So why? And the reason is the little cylinder, so it's not at a high temperature. It wasn't really hot. It was outside for a bit and it cooled off pretty quickly. More important, the line into the regulator was vertical up for maybe an inch or so, then straight across into the regulator, and then it was low pressure out to the barbecue. There isn't enough surface area to lose a lot of heat. There's no heat transfer area. And any liquid that did form would be able to flow back and down into the tank. So anything going forwards is just vapor. So that's why the little tank worked. But let's suppose we want that big tank to work. How do we do it? Well, I think the right way to do it is to put the regulator right on the big tank. And that way, any chance that the warmer, high-pressure vapors of condensing in the piping or in the inlet line to the regulator is much reduced. There's far less driving force. Well, there's less surface area for heat transfer. Liquids will just drain down. So anything that flows out is just going to be a vapor, and that's it. So that was the cause of why the barbecue would not stay lit, why the solution worked, and why we should, or how we should be piping this up so that we don't have that problem again in the future. Take care. Happy engineering.